Get in a spaceship. Go as fast as physics allows, the speed of light itself. Now start flying in a circle. 2 months later, you still haven't made it back to where you started. You didn't fly across a galaxy. You didn't fly between stars. You just went around the edge of one single object. That's not science fiction. That object is real. And today, it's not even the biggest thing we're going to show you. We're about to count down the 5 most monstrous black holes ever discovered, objects so unbelievably massive that some of them shouldn't exist according to the laws of physics as we understand them. And the one that currently holds the title of biggest might not even deserve it. Scientists themselves aren't sure. Stick around till the end, because the final black hole on this list is still growing right now, as you're watching this. Let's go. Before we chase giants, we need to understand what we're even looking for. Because here's the strange truth, nobody has ever actually seen a black hole. Not directly. Not once. That's because a black hole isn't really a thing in the way a planet or a star is a thing. It's a trap. A region where so much matter has been crushed into so little space that gravity turns into a one-way door. Get close enough, and even light, the fastest thing in the entire universe, can't move fast enough to escape. That invisible edge of no return has a name, the event horizon. Cross it, and you are gone. Forever. Not maimed by some monster, not vaporized by some death ray, just quietly erased from the observable universe, falling toward a center that physics can't even describe properly. And these things come in sizes. Terrifying, escalating sizes. At the bottom of the food chain, stellar black holes. The corpses of dead stars. When a star many times bigger than our sun finally runs out of fuel, it can't hold itself up anymore. It collapses. And if enough mass survives that collapse, what's left behind is a black hole, usually somewhere between 3 and 100 times heavier than our sun. Our galaxy alone is thought to be scattered with millions of these, drifting silently through the dark, completely invisible unless they happen to be feeding. And feeding is the only reason we can find any of these things at all. When gas or dust strays too close, it doesn't just fall in cleanly, it gets shredded, flattened into a spinning disk, and heated by friction to millions of degrees. That glowing, screaming disk of dying matter is the only signal we get. Black holes don't shine. Their meals do. Now take that idea, and scale it up to something almost incomprehensible. At the center of nearly every major galaxy in the universe, including our own, sits something in a completely different league, a supermassive black hole. These start at around 100,000 solar masses and can climb into the billions. Our own galaxy's monster, Sagittarius A star, weighs in at about 4.3 million suns. Sounds massive, right? On this list, it's a featherweight. Because once a black hole crosses 10 billion solar masses, astronomers actually run out of comfortable words to describe it. Supermassive isn't enough anymore. These become ultramassive black holes, and the absolute biggest of them get an even stranger, almost desperate label: stupendously large black holes. Yes. That is a real scientific term. Because apparently, at a certain point, scientists just give up trying to sound professional. So how do you even find something that, by definition, emits zero light? You look for the chaos it leaves behind. You look for quasars, black holes feeding so violently that the material around them outshines entire galaxies put together. You watch stars orbiting empty-looking space at impossible speeds, and calculate what invisible monster must be holding them there. You watch light itself bend around nothing, warped by a gravity well so deep it acts like a lens. And in 2019, for the first time in human history, we actually photographed one directly, the shadow of a black hole in a galaxy called M87, captured by linking radio telescopes across the entire planet into a single, Earth-sized eye. But here's the twist you need to hold on to for the rest of this video: the farther away these objects are, the blurrier our numbers get. Every mass you're about to hear is an estimate, some more solid than others, some revised, some slashed in half after better data came in. Even the black hole that's about to take the number one spot has scientists arguing over its true weight. With that warning in mind, let's meet the monsters. 700 million light-years from Earth, buried inside a crowded, chaotic cluster of galaxies called Abell 85, sits a galaxy that didn't just grow big. It grew big by eating everything around it. Its name is Holmberg 15A. And sitting at its very core is a black hole weighing an estimated 40 billion suns. Let that sink in. That's nearly 10,000 times heavier than our own galaxy's black hole. Its event horizon is so wide, it could swallow Neptune's entire orbit not once, but dozens of times over. But the real horror story isn't the size. It's how it got there. Holmberg 15A sits at the gravitational center of an entire cluster of galaxies. Over billions of years, smaller galaxies got pulled in, one after another, and slammed into it. And each one of those galaxies brought its own black hole along for the ride. Here's the part that should give you chills: when two black holes meet, they don't collide and stop. They spiral toward each other in a slow-motion death dance that can last millions of years, bleeding energy away as ripples in spacetime itself, gravitational waves, until finally, their event horizons touch, and two become one. Then it happens again. And again. Dozens of times. Maybe hundreds. And we can actually see the crime scene. The galaxy's core is strangely hollow and spread out, stars flung out of position by all that gravitational violence. That's not decoration. That's evidence. Oh, and one more twist: early estimates once put this monster at over 300 billion solar masses. Better measurements in 2019 knocked that figure all the way down to 40 billion. Still an absolute giant. Just not quite the god it was once rumored to be. 1.1 billion light-years away lies IC 1101, for years, considered the single largest galaxy ever measured, once estimated to stretch nearly 6 million light-years across. Try to picture that. Our entire Milky Way could fit inside it more than 60 times. And guarding the throne room at its center? A black hole of roughly 40 billion solar masses, and it's not sitting still. It's actively firing radiation outward as matter spirals across its event horizon. So how does a galaxy get this obscenely large? The same way Holmberg 15A did. By conquering. Over billions of years, smaller galaxies wandered too close, got captured by its gravity, and were absorbed one after another after another. IC 1101 isn't really a single galaxy anymore. It's the merged wreckage of hundreds of galaxies that used to have their own names, their own stars, their own history. And now, the empire has gone quiet. Its stars are old, mostly dim reds and yellows. New star formation has basically stopped, partly because its own black hole keeps blasting the surrounding gas with so much radiation that nothing can cool down and collapse into a new star. It conquered its entire corner of the universe. And then it went silent. Now we go back. Way back, to the very edge of cosmic time. Meet S50014 plus 81, a quasar so distant that the light reaching us right now left when the universe was practically a newborn. Its black hole also weighs in at roughly 40 billion suns, but the mass isn't even the shocking part. The shocking part is the timing. This black hole had already ballooned to that size in less than 2 billion years after the Big Bang. The universe today is 13.8 billion years old. This monster packed on 40 billion suns worth of mass in roughly the first 15% of all cosmic history. That should not be possible. Even feeding constantly, at the maximum rate physics allows, the math barely works. It's forced scientists to consider strange, almost unsettling possibilities that some black holes might skip the whole dead star origin story entirely, forming instead from massive clouds of gas collapsing straight into a black hole. No star required. Just a head start most objects don't get. Its event horizon stretches roughly 149 billion miles across, a shadow 40 times wider than Pluto's entire orbit. And it burns with the brightness of 300 trillion suns, about 25,000 times brighter than our entire galaxy combined. A monster. Born far too early. Growing far too fast. For a long time, this was the answer. If you'd asked an astronomer 20 years ago what's the biggest black hole ever found, this is the name they'd have said. 10 billion light-years away, so distant that we're seeing light from when the universe was less than a quarter of its current age, sits TON 618. Its estimated mass, somewhere between 60 and 66 billion suns. Heavier than the combined mass of every star and hundreds of galaxies like our own, combined into one single object. Its event horizon spans roughly 390 billion kilometers, 40 times the distance between our Sun and Neptune. A beam of light would need weeks just to cross from one edge of its shadow to the other. And here's a twist you won't expect: astronomers first spotted this thing back in 1957, and had no idea what they were looking at. For over a decade, they logged it as nothing more than a faint, boring star inside our own galaxy. Then in 1970, radio observations blew that assumption apart. This wasn't a star at all. It was one of the most powerful quasars ever recorded, sitting not just outside our galaxy, but billions of light-years beyond it. When scientists finally studied its light properly, they found matter swirling into it at over 7,000 kilometers per second. Speeds and temperatures like that don't happen by accident. Only one thing in the universe can produce numbers like that, something almost incomprehensibly massive, pulling everything toward it. TON 618 sits right at the theoretical breaking point of what a black hole should be able to become. Push past a certain size, and the disk of material feeding it should start forming its own stars, which would choke off its food supply entirely. TON 618 looks like it's knocking directly on that ceiling. For years, this was the biggest thing we knew of. Then we found something bigger. 8.5 billion light-years away, at the heart of a sprawling collection of roughly 1,000 galaxies called the Phoenix Cluster, sits a single galaxy known as Phoenix A. And buried at its core is what may be, right now, as far as we know, the single largest black hole in the observable universe. Its estimated mass, 100 billion suns. Over 25,000 times heavier than our own galaxy's central black hole. Its event horizon spans roughly 590 billion kilometers, about 3,900 times the distance from the Sun to Earth. Line that up against Pluto's orbit, and Phoenix A's shadow is still roughly 100 times wider. And here's the part that should really unsettle you: it is not finished growing. Phoenix A is packing on roughly 60 solar masses every single year. That means, right now, while this video plays, this object is gaining the equivalent of an entire extra sun's worth of mass annually, like clockwork, with no sign of slowing down. How does something get this catastrophically large? The leading theory: multiple supermassive black holes, born in the chaos of the early universe, colliding and merging together, not once, but repeatedly until several giants became one true titan, possibly not long after the Big Bang itself. We even have physical proof of its temper. About 100 million years ago, Phoenix A unleashed one of the most powerful eruptions ever detected anywhere in the universe, carving out cavities in the surrounding gas that stretch hundreds of thousands of light-years across. But here's the honest twist, and it's important: that 100 billion figure isn't a direct measurement. It's a model, built from indirect evidence, because Phoenix A is simply too far away to weigh with total certainty. Some scientists think the real number might actually be closer to 40 billion, which would knock it back down into the same league as the other giants on this list, instead of towering above them. So is Phoenix A really the biggest black hole in the known universe? Right now, it's our best guess. But best guess is doing a lot of heavy lifting in that sentence. And somewhere out there, in a corner of the universe we haven't pointed a telescope at yet, there might be something even bigger, quietly growing in the dark. 5 monsters. 5 corners of space and time. And the unsettling truth is, we've probably barely scratched the surface. There are almost certainly bigger, darker giants out there that we simply haven't found yet. So, which one of these blew your mind the most? Drop it in the comments below. And if you want to keep exploring the strangest, most extreme corners of our universe, make sure you're subscribed. Because trust me, this is just the beginning.